Hello, everyone. I am Mark Nadal, and I am doing an exuberating talk on performance. So exciting. We get to talk about performance, because does anybody really care about JavaScript performance? I'm Mark Nadal. Why should you listen to me? Well, I am working on a JavaScript database. You can think of it as an open source Firebase. Somebody decided to use that database as a game engine for their JavaScript-based browser-based game, and I learned all the mistakes that I made in writing my system. So I realized, OK, we need to re-engineer everything for performance first. That's something that's not the usual thing you're going to hear. But I didn't care about performance before, and then it hit me in the face, and I realized, OK, performance is actually something I have to think about. So I'm going to start off with a controversial statement that what you're about to see here might be against best practices. However, don't trust anything that I say, because we're going to do it all by example. So let's only trust the numbers. So to start out with, who knows how fast your computer in your preferred browser can execute nothingness in JavaScript? How many ops per second? Does anybody know that answer? No? OK. So we're going to find out some of those interesting things.
Video at the same time?
Video?
Yeah,
Whoa.
do you have Windows Media Player open or not?
Oh, that's true. Just running one thing at a time without multitasking.
That's not. When you have Windows Media Player, you get events at a faster rate.
Yeah.
When you have Windows Media Player on, you get browser events at a faster rate.
I did not know that. See? Lots of interesting things. So before diving too much into performance and micro-optimization, I want to first state that you can get lost in an infinite world of doing performance optimization. So I'm trying to espouse something similar to TDD, test-driven development, that I'm calling PTSD, which is performance testing speed development. And the reason why it's shocking is not so much for our sake, but because we wind up torturing our machines with these tests. The point of it is that it gives you something very practical, very quickly to just throw up, test against, see whether something is faster than a comparative thing, and then jump back to code. So that way you're not losing all this time thinking, oh, is it a reverse while loop or a forward while loop? Those things wind up changing so much. And just in the last kind of 9 months that we've been tracking browser performance, we have seen tons of changes. So for instance, Chrome talked a lot about how, oh, we're doing cache inlining in functions. So if you have tons of functions and compose them together, it's all going to just be inlined and really fast. Well, technically not. They weren't doing that for a long time. And we saw that actually in the numbers. But slowly over time, now that Chrome's upgraded and we've gone the Canary release, we're actually seeing that those things have changed and things are faster. So performance changes all the time, and especially across different vendors. So you've got to be very, very cautious and very careful not to get lost in a sea of the world. And that's why PTSD is going to actually be helpful in us just still writing our product, still making progress without being too confused about that. All right, so let's jump in. I'll give the link to this afterwards, which goes through a bunch of different example test cases, and I'm going to have you in the audience guess which process is faster. But before we do that, I want to show you what it can result in. So our JavaScript database, which is like an open source Firebase, as I mentioned, if we run the tests on it, baseline of doing nothing in JavaScript is only 128 million ops per second on a MacBook Air in Chrome. This is sad because 6 months ago I ran this exact same test and it was doing about 1.4 billion ops a second. However, I do want to note that while nothingness in Chrome has slowed down over time, other things have actually sped up. So what we're achieving here is saving data is about 8,000 plus operations a second. You don't really have anything to compare that to, but this number here, I think, gives us a more interesting number, which is 46 million ops per second. The last time I checked Redis, and Redis complains that you have to be careful about benchmarking things, and it's very, very, very true, and that's what we're going to be going over. Redis did about 750,000 ops per second on a read, and this is about equivalent. So this is over 60 times faster than that. So just as a comparison, this is absurd, especially when you look that the baseline of doing nothing in JavaScript is 128 million ops per second. So if you pay attention to performance and just use some simple techniques, you can wind up realizing that this approach is, a million ops faster than this thing, and you don't have to think about it too much, but you can choose the one that's just slightly faster. If you do that for most of your code, so we're not wasting time, you're just testing it really quickly and getting back to work, over time you have saved millions and millions of operations a second that your code will actually be able to execute quickly. All right, so now let's jump into the fun things. So doing nothing, as you already saw, was about 128 million ops. There's jitter every single time you run them. The computer just has slightly different edge cases, whether it's running Windows video or Windows Media's player or not. So doing nothing, 130 million ops a second. So what if we assign a Boolean? Var I equals true. Who wants to take a guess at how fast this will be? 100 million ops? OK. All right, let's run. 120. So it looks like at this rate, we're not losing any performance. In fact, it actually looks like it's a little bit faster because there is jitter here. So assigning a Boolean, basically no work needs to be done. It's great. So what about assigning text? Anybody want to take a guess? 70 million ops a second. OK, let's run it. We're going to have to get fast about this because we've got lots of tests to go over and lots of things to explain. So just shout it out and we'll move forward. So 128. So it's slightly slower, but not much. Text is basically free. All right, now let's add two numbers together. Who wants to guess how fast that is? OK, let's run it. 100 and let it go through all its cycles. Sweet, 130 million ops a second. So we're not losing much doing these pretty primitive operations. All right, so now we're going to call a function add12 that all add does is return a plus b. Who wants to bet how fast that's going to be? 130 million ops a second. OK, going once, going. Wait, did I just rerun? There we go. All right, so we just went from 130 million ops a second, calling one function with a plus operator inside of it, okay, because we just did plus right up here, and it was the full 130. We just halved our performance by calling the function, adding those things together. Calling a function, people, you probably do that a lot in JavaScript, because if you don't, you might be using goto. Actually, I don't think JavaScript even has goto. All right, now we're going to assign an object. I'm actually going to decrease the font a little bit. How fast do you think assigning an object with a Boolean, a number, and a text inside of it is going to be? OK, 50 million ops a second, oh, a little bit higher. So it's almost as fast as calling the function itself, actually a little bit faster. All right. Now we're going to assign an object, and it's going to be a circular reference. Is there going to be any difference between these two? OK, let's run it. Got to actually click that button. Well, we actually lose a little bit of performance here. Probably because internally, well, I actually don't quite know what's going on internally, but having the circular reference there is doing something to cause it to be 10 million ops per second slower. That's kind of interesting. All right, now we're going to assign Boolean, number, text, list, an array, as well as an object that has those things inside of it. I'm just going to go for it.
Can I point out a difference on the previous one?
Yes.
On the previous one, you're adding a property. That's different than.
That is true. So internally, the V8 engine, because we're in Chrome, winds up having a hidden class for the initial object that we created. But once we've mutated that object, it has to create a new hidden class because we've changed the structure of the object. And the only reason why it has hidden classes internally is because it's trying to give us performance gains. Now, if you run all these tests in Firefox, you're going to get very different results. Turns out that Firefox, at least for the last 8 months, was way, 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 way faster than Chrome's V8 engine because they were actually inlining functions, despite the fact that Chrome claimed they were inlining functions. So good point, yes. All right, now we're going to have objects that have numbers on them that we pass into a function. And that function, I'll scroll up, which is probably going to affect the performance. It's going to be the same add function, except for us just adding the properties together. So there's property access going on here. There's function calls. And scrolling back down, 41 million ops per second compared to the 64 million ops per second. So most of either the libraries that you use, the frameworks that you're using, the code that you're writing probably isn't so low level you're just passing Booleans around, right? You're probably actually passing objects, making function calls. Those function calls are calling other functions. Those add up over time. But now let's get into the conditional logic. What about an if statement? If true, 1 + 1. Who wants to bet how fast it's going to go? I heard a 90 million ops per second. Oh, I keep on missing. So this is compared to doing nothing, which we'll scroll back up to once it finishes, right? 130 million ops per second. This if statement actually doesn't take too much off of our code. So that's fantastic.
So what effect would branch prediction have on a condition like that?
Well, so this was, you probably have to explain yourself, but I think where you're going is that this next statement has a bunch of if statements where those if statements are false conditions, and the very last one winds up being the truthy condition. I'm going to run this one. Do you guys think it's going to be, and then I'll come back to your question. Do you think this if statement where 9 is not less than 1, 8 is not less than 2, 7, it's got a bunch of if statement it has to go through, and at the very, very end we get to our final case. Do you think this is going to be any slower or faster? It's going to be same. We've got a lot of same. So it turns out 6 months ago this was significantly slower, and I encouraged people to always put hot paths to their code as the very first if statement. However, I woke up today, reran this, and that, I mean, let me just rerun this again because there's always slight jitter. I don't know what happened in the last 6 months, but since my Chrome upgraded the last couple of times, Chrome, I'm using benchmark.js underneath. So this wasn't my own library that I wrote for testing, so there shouldn't be any. I wonder, actually, maybe, are they doing branch prediction in here to?
That's something your OS is going to do. They're doing
For you?
the same time over and over, right? Like if true, once it does if true once, it's going to cache that, right?
Right. And it's re-performing the exact same test millions and millions of times per second. So it should be getting really good at branch prediction here. I have no clue whether, I mean, like, I did not see this earlier that morning. That's why I said, don't trust anything I say. Look at the numbers. They are sometimes interesting. So I don't know enough about branch prediction, but I'm guessing branch prediction is saying that the code went through this branch so many times, let's optimize that, it makes it faster. Historically, I've seen even in JavaScript that you manually doing that, putting your hot paths first, gives you significant performance increase. But I woke up today and it's not, but I'd still recommend you guys do that. The problem if you, depending upon your style of JavaScript, if you do branch prediction, that means your main code path keeps on getting nested and nested and nested of if statements. If you use the style that I typically use, which is your main code path is the last remaining if statement, because all the if statements are basically type checks and if statements to cancel the operation. So that way my main logic stays like only one nested in. That winds up being, well, should be slower because it has to go through the other checks first. But black magic of the V8 engine, I guess. If somebody can explain this to me, I'd love them to. All right. 4 statements, woohoo! Who's excited about loops? Okay. 4 statement that's uncached versus a 4 statement that is cached. And well, that didn't do much good. Where we declare var I is equal to 0 inline versus this one where var I is declared outside and then we use it. Which one's going to be faster? Raise of hand. Is the cached loop going to be faster? Wow, there's a lack of trust in Chrome here. All right. Looks like we're doing about 25 million ops per second. Maybe I can scroll up to show you what that list is. That list is just 9 integers, okay? So underneath, Chrome should be able to convert this into UNT. I don't know what the terms are. All right, so 25.9 million compared to the 4 cached. Does anybody want to make a guess what the cached one is going to perform? 70 million? It's not terribly much faster, but this is why PTSD is awesome, because if you just take these 2 things, quickly paste it in, hit run, you see which one's a couple million ops faster, and then get back to work. You don't have to ask the question of micro-optimization and all that junk. You just write code, toss it in, test it, and go back. And you then slowly over time get millions and millions of ops faster. And then if you really want to get into it, you actually study this thing for a long time. All right, now using the all-wonderful, convenient list.forEach built-in function. How fast do you guys think that that's going to run? 10 million ops per second. Who saw that coming? OK, so let's use this handy calculator. You probably wonder, well, no. Copy, paste, copy, paste, because I can't do math in my head. 6 times faster to use the approach that you always forget how it works. And, well, because you're performance-oriented, obviously you use the unmaintainable approach and then make it be a nightmare for other developers to come around and remember, wait, do I have to do it? Is it less than or equal the length of the array? Or so convenience, readability, .for each, but 6 times slower. Ooh, but if we take that exact same function at the top, I actually already forget what that function was, iterate, which actually doesn't do anything inside of it at all, and cache the function and do for each, how fast is it going to be? 10 million? 50? Did somebody say 50 million? 15 million. Nope, sorry, people. And that iterate function, as I just showed you, didn't do anything inside of it. So Chrome V8 engine should be saying, oh, that's a no-op, don't actually call it. Nope, sad day. If you put this in Firefox, it's going to be a big difference. So it is faster than the uncached one, but not compared to a raw for each. All right, using the same for each approach, but doing it with while loops. How fast is this while loop going to be where it's a standard while loop moving forward through the list? 22? It's significantly faster than the .for each, but it's about half the performance of the regular for statement. All right, now reverse while loop. Who's going to put the money on this one? 7 million ops per second. OK. Whoa! Ladies and gentlemen, a reverse while loop is fast. 31 million ops per second. So in this case, it's a little bit faster than the cached for loop. Now, this was the case 8 months ago that the reverse while loop was consistently performing faster. In the in-between time for the last 6 months, a regular cached for loop was always the winner and being faster. So Chrome has changed their engine slightly again. Now, I'm still going to encourage for performance purposes to use a cached for loop, okay? Because while the reverse while loop is being a little bit faster, a cached for loop should be a little bit more maintainable and comprehensible to a next developer. And if you really want readability and maintainability, go with the .for each. The other thing here is that these numbers change so much. So it's generally speaking better to stay with the more consistently known for loop, which is the cached for loop, because that's likely going to be optimized more and more in the future versus a reverse while loop. And besides, a reverse while loop also limits some of the things you can do. You also have to note that for the cached for loop, there's limitations to that as well, which if you have an array that inside of your for loop, you are then mutating that array, so the array length is changing, you're not able to cache it. So there's tiny little things you have to be careful. You got to make sure your business logic is correct, because if your business logic runs at 140 million ops per second, but is just dev null, or doesn't do anything, well, that's not particularly useful. So again, even if we're focused on performance, don't sacrifice correctness. OK, type checking, because JavaScript doesn't have really type checking in it. So this was a lot slower 6 months ago. And because in the library that I write, I'm often checking for a callback. It's really, really nice that they've improved the performance on this, because, come on, knowing whether something's a function or a string or something, that language, please, JavaScript, please be fast. Now, is it going to be faster to use the instance of approach or the triple equal equivalence to a string function? Who is going to say that the string approach is faster? Well, not very many people are being interactive, not willing to take bets. So this is running about the same speed as nothingness, apparently. Let me check time. Oh, OK. We only have 5 minutes left? OK, then I'm going to jump past a lot of these things. Turns out lots of the new fancy features are really, really, really slow. This is the most important thing that you need to take away, though, is function calls. Because at the end of the day, this is what's going to kill you. We're getting about 78 million ops per second with a single function call. We're going to run a second function call. The performance is going to half down to 30-ish. I guess that's a little bit more than half. However, it becomes slightly logarithmic if I did this correctly. This one's not going to be half of the previous one, but it's going to be slower. And if we're going on to the next one, it's going to be still slower. It's going to be like 18 million ops per second. So every single time we add a new function call, we're basically logarithmically decreasing our performance. So functions are really important. They're like the bread and butter of programming. But it turns out with JavaScript, it winds up being really slow. And these functions are already cached. OK? And we keep on going. So I'm going to end. Wow, this is so fascinating here. We have a function down here that params a, b, c. And we have another function. They both do nothing that has no parameters in them. Okay? So they're exactly the same, except for one has parameters, one doesn't. I lose my place now because, all right, let's run it. So single function call. It's compared to a single function call that had no, well, I'm giving it away. So just having parameters, even though you're doing nothing with them, is ripping out like 20 million ops per second. So there's lots of little gotchas here. And I'm going to skip these things. Apply winds up being bad. Call winds up being better, but not as good. The important thing is the anonymous function. So we're going to have some code here, which anonymously inside of it creates a couple variables. And then it creates some state. And it calls inside of that another function, which has the outer scope. Okay? And then inside of that, we access a property in one of the outermost scope. Okay? This is the most important thing that I'm going to have to teach you with this talk, which is there's tons of performance advice out there. But the biggest difference is not only the function calls, but whether we cache those functions. So outer, at the very, very, very top here, winds up doing the exact same thing, except for it takes those internal functions and pulls them out. Okay, so A1, B2, and then object. And we call middle, which was the inner scope. And the middle does the same thing, and then inner calls that inside of that. Okay, let's run it. All the functions internally are cached. And our performance just went way back up from the 2 million ops per second to the 24. So there's orders of magnitude performance improvement here. But the one caveat and trade-off with that is that you actually have to manage scope yourself. Because if you have anonymous functions, the scope carries through the nested functions. But if you have these named functions that you call internally, you don't get scope. And it turns out that it is the creation of that scope and the creation of those functions and the calling of those functions that winds up going from the 24 million ops down to the 2 million ops per second. So if you're interested in performance, if you manually just cache all of your functions as named functions and then call it with the scope that you want, always explicitly passing the data, you get orders of magnitude performance improvement. So it's probably not useful to your regular old web app where somebody clicks on something and it runs once, right? Because a human being is not going to be clicking millions and millions of times on that function. But it is good to know what the black magic underneath is doing. Well, maybe we don't know what the black magic is doing, but we know how it is behaving. So let's end with json.stringify. All right, thank you, everyone. I hope you enjoyed this talk on performance. If you want to, run these tests yourself on your own computers with a MacBook Air, you're going to get wildly different results. It's fun to watch the base case of your computer with doing nothing. Hit that URL. And if you follow all these techniques of PTSD, you can eventually build a database that does almost 50 million ops per second on a read. Thanks so much.